Hi students, today we discuss the topic multiple integrals, concept, evaluation of triple integrals and regions. Contents, objective and outcome, evaluation of triple integrals, regions, working rule and applications. Objective and outcome. The objective is evaluation of triple integrals and reason of integration in triple integrals. The outcome will be student get to understand about the concept of evaluation of triple integrals when the reason is given. Evaluation of triple integrals. For evaluation purpose, three integrals over v f of xyz dv is expressed as the repeated integral. The repeated integral is integral x1 to x2, integral y1 to y2, integral z1 to z2, f of xyz dz dy dx, where in the order of integration depends upon the limits. If the limits z1 and z2 be the functions of xy, y1 y2 be the functions of x, and x1 x2 be the constants. Here z1 z2 are in terms of x and y1 y2 are in terms of x, and last outer integral limits are x1 x2, those are constants. Then we have to evaluate the integral like this. That is, z limits are here in terms of xy, integration with respect to z, most inner integral, and then outer integral limits. Y limits are in terms of x, integration with respect to y, most outer integral, that is integration with respect to x, because here x limits are constants. That is I is integral of x equal to a to x equal to b, y limits phi1 of x to phi2 of x, z limits f1 of xy to f2 of xy, integrand function is f of xyz, order is dz dy dx, which shows that the first f of xyz is integrated with respect to z, keeping xy as constant. The most inner integral is integrated with respect to z. While integrating with respect to z, we have to kept xy as constant. Between the limits, z is f1 of xy to f2 of xy. The resultant, which is a function of xy, is integrated with respect to y. While integrating with respect to y, we have to keep x as constant between the limits phi1 of x to phi2 of x. Finally, the integrand is evaluated with respect to x. Thus, the triple integration finally becomes the single integration, which is evaluated with respect to x under the limits x equal to a to x equal to b. Note, this order can accordingly be changed depending upon the comfort of integration. For our comfort, the integration order can be changed. Evaluation of triple integrals, region problem. Evaluate a triple integral over v xy plus yz plus zx dx dy dz, where R is the region of a space bounded by x is 0, x is 1, y is 0, y is 2, z is 0, z is 3. So here R is the region is given. The volume region is bounded with six surfaces. Now we have to evaluate this triple integral. Solution: given triple integral using the limits, that is x varies as 0 to 1, y varies as 0 to 2, and z varies as 0 to 3. So just fixing the limits, now we have to apply integration with respect to x and then y and then z. While integrating with respect to x, we have to keep other variable terms as constant. That is, yz is treated as constant. So y is keep it as constant. X integration is x square by 2. Yz is treated as constant. One integration is x. So xyz. Here in last term, z is keep it as constant. Just keep it as a silent. X integration is x square by 2. Limits of x are x varies as 0 to 1. Now substituting upper limit as 1 and lower limit as 0. Since we are applied integration with respect to x and these are the limits related to x, we have to substitute in place of x. Substituting upper limit as 1 and lower limit as 0, we will have the expression like this. Now the function integrand function is in terms of yz. Now clearly the triple integration is now becomes double integration. Now we have to apply the integration with respect to y. While integrating with respect to y in double integrals, keep z terms as constant. That is, z is keep it as constant, y integration is y square by 2. Similarly, other terms are also integrated, but z is keep it as silent. Now substituting upper limit as 2 and lower limit as 0. Now clearly the triple integration is now becomes a single integration. We have integral 0 to 3, 1, 2z plus z is 3z dz. Now integration for 1 with respect to z is z, 3 constant, z integration is z square by 2. Substituting upper limit as 3 and lower limit as 0. We will have 3 plus 27 by 2. Taking the LCM as 2. 2 3s are 6. 6 plus 27 is 33. 33 by 2 is the required result. Evaluate the triple integral, integral 0 to 1, integral 0 to 1 minus x, integral 0 to x plus y whole square, x dz dy dx. Solution: given integral, that is I. Here we have to apply integration order with respect to z and then y and then x. Because z limits are here in terms of xy, y limits are in terms of x, and last outer integral limits are x limits. Those are constant limits. So the order is correct. Then I is, while integrating with respect to z, we have to keep x as constant, x keep it as a silent. One integration is z. Z limits are 0 to x plus y whole square. Now substituting in place of z, upper limit and lower limit. Upper limit minus lower limit. Now clearly the triple integration now becomes double integration. Now while integrating with respect to y, we have to keep x as constant. Simplifying, so we will get that clearly we will have the triple integration is now becomes single integration. Now applying integration with respect to x, substituting upper limit and then lower limit. Now applying with respect to x. Before that, simplifying the single integration. So clearly simplification becomes like this. 1 by 3 is taken out. X power 4 integration is x power 5 by 5. X integration is x square by 2. Substituting upper limit as 1 and lower limit as 0. So we have substituting upper limit as 1 and lower limit as 0. and simplifying by taking the LCM, we will get the result as 1 by 10. Hence, the required triple integral value is now 1 by 10. So simply we can find the triple integration value while integrating with respect to z and then y and then x. Just give the preference for variable limits. At last, the preference for constant limits to get the result as constant. Another problem, evaluate the sum. Here z limits are in terms of xy, y limits are in terms of x, and x limits are constant. But the given order is dx, dy, dz. First we have to take the solution, that is the inner integral is I. First we have to correct the form. Now we have to integrate first with respect to z. While integrating with respect to z, we have to keep xy as constant. E power z integration is e power z. Substituting upper limit as x plus y and lower limit as 0. Now clearly the triple integration sum is now becomes double integration. Now while integrating with respect to y, we have to keep x as constant. E power x plus y integration is e power x plus y. E power 0 is 1. 1 integration with respect to y is y. Now substituting upper limit as 1 minus x and lower limit as 0. So in place of y is substituted because these limits 0 to 1 minus x are the limits related to y. We have to replace only in place of y. Now clearly the triple integration sum is now becomes single integration. Now we have to integrate with respect to x. Before that we have to simplify the expression. Now applying integration with respect to x, e integration is ex, negative 1 integration is negative x integration is x square by 2, e power x integration is as it is e power x. Substituting upper limit as 1 and lower limit as 0. So we will get negative half plus 1, that is half. So it is the required value of the given triple integration. So here in triple integration evaluation, the order is important. So here we have to apply integration first with respect to z and then y and then x. In given sums, in a given question, the order may be given as like this, but we have to change. First we have to change the order and then we have to correct the order and then we have to evaluate the triple integral like this. So hence the required value of the triple integral is 1 by 2. Problem. Express the volume of the sphere x square plus y square plus z square is a square as a volume integral and hence evaluate it. So first we have to express the sphere region as a volume integral and then we have to evaluate. So here in this diagram clearly only first octant region is given. The triple integration volume integral is given by integral minus a to a integral negative root of a square minus x square to positive root of a square minus x square, negative root of a square minus x square minus y square to positive root of a square minus x square minus y square. The integrand function is 1 here. Clearly 1 is an even function or odd function? Even function, because every constant function is always even. 1 is an even function, so that negative root of a square minus x square minus y square to positive root of a square minus x square minus y square can be written as 2 into integral 0 to root of a square minus x square minus y square. Since we have a definite integral formula, that is integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx whenever f of x is an even function. Using the formula, we can write 2 into 0 to root of a square minus x square minus y square. So here the limits of z are in terms of xy, because clearly in this pic we have z varies as 0 to root of a square minus x square minus y square, because The strip lower part is touches to the xy plane. In this xy plane, z equal to 0, and the strip upper part touches to the sphere. The sphere equation is x square plus y square plus z square is a square, which implies that z square is a square minus x square minus y square. Hence z is plus or minus root of a square minus x square minus y square. But here we are taking positive square root because in first octant all xyz are positive. Similarly, the volume region lies in eighth octant also. So in that we will have to take a negative root of a square minus x square minus y square as a limit of lower limit of z, because the strip is extended to lower side and the strip is touches to the sphere. So for this we have to take z as negative root of a square minus x square minus y square. So z limits are negative root of a square minus x square minus y square to positive square root of a square minus x square minus y square. But here we are taking 2 into, because the integrand function is an even function. And then the orthogonal projection is like this, that is the circle equation is x square plus y square equal to a square, whose limits are y limits are minus root of a square minus x square to positive square root of a square minus x square, and x limits are constants, that is negative a to positive a, which are already discussed in the evaluation of double integrals while doing the sums related to circles. So clearly it's a triple integration becomes double integration. That means we have to take the volume region in two-dimensional. That is, the orthogonal projection is considered in two-dimensional, so that the volume region is like this circle, whose limits are negative root of a square minus x square to positive root of x a square minus x square, and x limits are minus a to plus a. Now apply integration first with respect to z. One integration is z, substituting upper limit as root of a square minus x square minus y square and lower limit as 0. So we will have double integration. Now we have to apply integration with respect to y. We have to keep x as constant. Before that, if we take a square minus x square as a sum b square, then it is easy to evaluate the double integration. So it is look like a formula, that is integral of root of a square minus y square dy. So using the formula we can expand it. Now substituting upper limit as b and lower limit as 0. So we will get like this. But sine inverse 1 value is a pi by 2. Taking out pi by 2 as constant, clearly 2 get cancelled. But what is a b square? B square value is a square minus x square. Now we have to apply the single integration with respect to x. So pi constant, a square integration is a square x, and x square integration is x cubed by 3. So here the integrand function is an even function. The limits minus a to a can be written as 2 into 0 to a. So that we have to take upper limit as a and lower limit as 0. So substituting and simplifying by taking the LCM as 3. So we will get the result as 4 pi a cube by 3. It is the required volume of the sphere having radius 3. That is a 4 by 3 pi a cube, where a is the radius of the sphere. Another problem. Evaluate integral 1 to e, integral 0 to log y, integral 1 to e power x, log z, dz, dy, dx. So here we have to apply the integration first with respect to z and then y and then x. So solution, while integrating with respect to z, we have to keep xy as constant. So z1 limit is 1 here and z2 limit is e power x plus 0y. So clearly z limits are here in terms of xy. Now the integrand can be obtained by using integration by parts. That is, first function is here log z and another function is here 1. So taking the integration by parts, integral u dv is uv minus integral v du. So integration by parts and then substituting upper limit as e power x and lower limit as 1. In place of z, we have to substitute. Now clearly the triple integration sum is now becomes double integration. We have to solve this double integration. So simplifying the expression, now while integrating with respect to x, we have to keep y terms as constant. So x e power x is integrated, substituting upper limit as log y and lower limit as 0. For first term, we have to apply integration by parts again. Y plus 1 is first function and log 1 is second function. So taking integration by parts, so we'll get the expression like this. We have to replace the upper limit as e and lower limit as 1. And then simplifying the single integration. So we will get the result as 1 by 4 into 1 plus 80 minus 3 e square. So hence the result of triple integration is obtained. Another sum, same sum here, only the lower limit is changed here. The lower limit is here 1. So given integral, first with respect to z, log z integration by parts is z log z minus z. Substituting upper limit as e power x and lower limit as 1. Clearly triple integration sum is a double integration. While integrating with respect to x, x e power x integration is x e power x minus e power x. Negative e power x integration is negative e power x. 1 integration is x. Substituting upper limit as log y and lower limit as 1. Clearly now the triple integration sum is reduces as single integration. Taking the integration with respect to y under the limits 1 to e. Substituting 1 to e limits and taking the LCM as 1 by 4. Taking out the common as 1 by 4, we will get the result. Evaluate the triple integral x plus y plus z dx dy dz over the tetrahedron bounded by the planes x is 0, y is 0, z is 0 and x plus y plus z equal to 1. So given region is a tetrahedron. Solution, the integration is over the region or shaded portion bounded by the planes x is 0, y is 0, z is 0 and x plus y plus z is 1. So it is the shape of the region, rough sketch of the region. So it is a tetrahedron. So clearly we have 4 surfaces, bottom surface xz, yz and front surface, that is x plus y plus z equal to 1. So tetrahedron having 4 surfaces or 4 planes. X is 0, y 0, z 0. X is 0 means yz plane, y equal to 0 means xz plane, z equal to 0 means xy plane. So inner region is a volume region, that is a tetrahedron. Here we have to take a strip parallel to z axis. So that z limits are obtained. Z limits are 0 to 1 minus x minus y are the z limits, because the strip lower part touches to the xy plane. So z equal to 0. Upper part of the strip touches to the plane, that is x plus y plus z equal to 1. Here in that z is 1 minus x minus y. Now likely the volume region, projection region is considered in, the projection is considered in xy plane. So here x varies as 0 to 1 and y varies as 0 to 1 minus x, because the volume region orthogonal projection in xy plane is like a triangle. In that z is 0, so we will have the line equation, AB line equation is x plus y equal to 1. Here z becomes 0. Just delete it z, x plus y equal to 1. So we will have x plus y equal to 1 as a region, that is a triangle region. So in that y varies as 0 to 1 minus x, because taking the strip, the lower part of the strip touches to the x-axis, so that y equal to 0. The upper part of the strip touches to the line, that is x plus y equal to 1, where y is 1 minus x. So y limits are obtained. Y limits are in terms of x. Now x limits must and should be constant. So x-axis points are, extreme points are 0, 0 and 1, 0. But here x varies as 0 to 1, so that the limits are obtained. Whenever we are having limits, we can evaluate the triple integration easily. So once again, according to volume region, just draw a strip in that volume region. The strip lower part touches to the xy plane, so z equal to 0. Upper part of the strip touches to the plane, given plane, that is x plus y plus z equal to 1. So that z is 1 minus x minus y. The z limits are in terms of xy. Now the volume region, projection region is considered in xy plane. That is now three-dimensional figure. Now it becomes a two-dimensional, as only we are having the triangle region. That is, only we are having y-axis, x-axis and the line x plus y equal to 1. So here we have to take the strip again, which is parallel to y-axis, so that the strip lower part touches to the x-axis, so y equal to 0. Upper part of the strip touches to the line x plus y equal to 1, so that y is 1 minus x, and x limits should be constants. But x-axis vertices here 0, 0 and 1, 0. So x varies as 0 to 1. So clearly limits are obtained. Now we can evaluate the triple integration. So given triple integration, substituting the limits, integrating with respect to z, keeping xy as constant, that is xy is treated as a silent, substituting upper limit as 1 minus x minus y and lower limit as 0 in place of z, because these are the limits related to z. Now clearly triple integration sum is now becomes a double integration. Now evaluating the double integration with respect to y and then x. While integrating with respect to y, we have to keep x as constant. Just simplifying, now we have to apply integration with respect to y. So that is, one integration is y, x plus y whole square integration is x plus y whole cube. Substituting upper limit as 1 minus x and lower limit as 0. Now evaluating the single integration, we will get the result as constant, that is 1 by 8. So it is the required result. So simply we can find the evaluation of triple integral. So this is about the topic of triple integration evaluation when the region is given or the limits are given. For any queries, please contact. Thank you.